Good morning, class. We are looking at the inverse trig functions. We have covered graphs of the sine and cosine, tangent, cotangent, cosecant, and secant. Phase shift, we looked at more graphs, sinusoidal functions carefully. Now we're going to look at inverse trigonometric functions, sine, cosine, tangent, and others. So we're going to find the exact value of an inverse sine, cosine, or tangent function. We're going to approximate. We're going to use properties of inverse function to find the exact value of certain composite functions, and we want to find the inverse functions of the trigonometric functions. And we're going to solve equations involving them. Equations involving inverse trig functions. So a quick reminder of what we have learned as far as trig is concerned. You have a unit circle, x squared plus y squared equals 1, and every point has coordinates x comma y, which represents cosine and sine. When the radius is a general radius other than 1, then the formulas change slightly. For example, sine is simply y, cosine is x, but in this case, sine becomes y over r, and cosine is x over r. Periodic functions, the period for every trigonometric function is 2 pi, with the exception of tangent, and with tangent goes cotangent, which would be pi. Every trigonometric function is an odd function except cosine, and therefore secant is also an even function. Fundamental identities, Pythagorean identities, quotient identities, reciprocal identities. Graphs of sine and cosine, if you're looking at a complete cycle, goes from 0 to 2 pi, and you cut it into 4 arcs to graph it. Same thing happens with the cosine. The domain is 0 to 2 pi, and you cut it into 4 arcs to graph him. That would make it fairly nice and easy. And the relationship between sine and cosine is that sine is cosine of x minus pi over 2. And if we have a general format of a sine omega x or a cosine omega x, the period is 2 pi over omega, and the amplitude is a. The inverse sine, cosine, tangent function So here's the synopsis of inverse functions, and we will look at them with more details in a moment. For a sine function, we do the restriction, and we have its inverse. For the cosine, we do the restriction, we have the inverse. And we do the same thing for the tangent, we do the restriction, and we have the inverse. What do we mean by that? Let's actually cover the details as to how we arrive at that in a moment. Also, as far as the phase shift is concerned, when we have the general form, and by the way, in some text, they may write it in this format: y equals a sine b times x minus c plus d. So in case you see that, you can compare it to this formula. So it depends on the text. Some texts, they want to go with different variables. In any event, it's important to know the number sitting in front of sine or cosine, the absolute value becomes the amplitude. the number in front of the parentheses, you put it underneath the t, and that represents the new period. And the phase shift is this number. So in this case, phi over omega. And if it's positive, it's to the right. So that's the idea of a phase shift. And again, when we have that, when we do the shifting along the x-axis, then we look at the beginning, we look at the end, and we make up 4 pieces. Starting from here, here's another one, here's another one, here's another one, here's another one. So 1, 2, 3, 4 arcs, and that will help us with the graph. All right, so let's review the concept of an inverse function. Only one-to-one functions have inverse functions. F of inverse of x equals x, x is in the domain of f inverse, and f inverse of f of x equals x, x is in the domain of f of x. They're composite function, in other words. The domain of f is the range of f inverse. And the range of f is the domain of f inverse. The graphs of f and f inverse are symmetric with respect to the line or about the line y equals x. When graphed on the same axis, and the composition as it was mentioned, f of f inverse equals f inverse of equals x. And that's extremely important to understand. All right, so this was to remind everybody about properties of inverse functions. So what about sine? When we look at the sine function, it is not a one-to-one function because it fails the horizontal line test, and it's not a one-to-one function, so it doesn't have an inverse. However, if we do the restriction from negative pi over 2 to pi over 2, so this doesn't have an inverse, so it's not a one-to-one function. But if we restrict it to this portion only, now this is a one-to-one function, and it has an inverse. So y equals sine x. When we restrict the x between negative and positive pi over 2, that's the domain. The y goes from negative 1 to 1. This is a one-to-one function. Now, the way they restrict it, they want to cover the whole range. It's important to see this covers the whole range. And so y equals sine inverse of x, by definition means x equals sine y. X is between negative 1 and 1, because remember the range here is negative 1 and 1 for the sine x. For sine inverse, this corresponds to the domain. This is the domain for sine x, corresponds to the range for the inverse by definition. So we look at important points. Negative pi over 2, negative 1 will change to negative 1, negative pi over 2. 0, 0 remains because we are interchanging x and y. Remember, if the pair is a comma b, for the inverse becomes b comma a. So this one, pi over 2 comma 1 becomes 1 comma pi over 2. So we made the changes. This is for the inverse, and if we graph it, looking like this, the red one. That is the inverse of sine. All right, so with the restriction now we have the graph. And as you can see, they are symmetric with respect to the line y equals x. The blue one is, in this case, the inverse, sine inverse, and the red one is y equals sine x. So having said that, let's answer a couple of simple questions starting with sine inverse of 1. So the methodology by which we answer it is very simple. What is sine inverse of 1? We say, I don't know, x, y, z. Normally we go with alpha, beta, gamma, or theta because normally they represent the angle. So by definition of a sine inverse, sine theta becomes 1. This is a common angle, and you should know it's pi over 2. And this will always have a unique solution. Sine inverse of 1/2, we do the same thing. Let's say we don't know the answer. We put it equal to something, x, y, z, or theta. If so, by definition, it means sine of theta is 1/2. And we are looking for an angle whose sine is 1/2. And of course, restricted from negative to positive pi over 2, it's pi over 6. Or 30 degrees. You answer it accordingly. This is in radians or 30 degrees if they ask to answer it in degrees. Sine inverse of negative 1/2, we do the same thing. What is it equal to? Theta, by definition. Sine of theta equals negative 1/2. And remember, 1/2 gives you pi over 6. And for sine theta being negative 1/2 is negative pi over 6 because of the restriction we have on the inverse. We're going to go from negative pi over 2 to pi over 2. And this is in the fourth quadrant where sine is negative. We're going to continue, and we're going to look at arcs that are no longer common arcs. So if I want to know the answer, I have to use a calculator. So I want to make sure that the calculator is in radian mode. Second, sine gives you sine inverse, and you put the 1/3 in, and it gives you this answer. You want it with 4 decimals, 1, 2, 3, 4. After 8 is 3, so it remains negative 1/4, not a common arc. Put it into a calculator. Second, sine, and then negative 1/4. So negative 0.252, look at this number next to it is 8. So it goes up to 7. Goes up to 7. So you want to take a look at the next number for the sake of rounding. Sine of sine inverse of 0.5. As you know, in the case of sine inverse, x must be between negative 1 and 1 for it to work. And because it's between negative 1 and 1, you just undo it. Sine of sine inverse is simply 0.5 because f of f inverse equals x as long as it's within the proper domain. And if you use a calculator, it gives you the same answer, by the way. Now, what about 1.8? If you look at this part, remember x must be between negative 1 and 1. You can just discuss this part only and say this is equal to x. That means sine x equals 1.8. And this doesn't exist because sine is between negative 1 and 1 only. Therefore, it's undefined. That's the justification because sine can only go between negative 1 and 1. And there is no solution. Undefined, does not exist. If you put it into a calculator, it gives you an error. It gives you an error. If you were to use a calculator, you make sure the mode is in radian. And then here's the sine. So you go second, sine, makes it sine inverse of, for example, 1 divided by 3, close the parentheses, you enter, and it gives you the number that we had here. So this is how you would use a calculator. All right, let's move on. I just wanted you to be exposed to the usage of a calculator. We are interested in finding sine inverse of sine of power 8. Now again, let's make sure we understand that in the case of a sine, the restriction is that we put it between negative power 2 and power 2, and the value of the sine, that means the range of y, becomes negative 1 to 1. So x can be between negative 1 and 1 here if we have sine inverse. But if you have a sine here, it has to be between these two numbers. Now, power 8 belongs to this domain, yes. So it just comes out as power 8. So since pi over 8 is an element of, let me write that, this looks like an epsilon. And we read this sign in set theory as an element of, that means it belongs to the following set. Therefore, the answer is simply pi over 8. If you look at five pi over 8, 5 pi over 8 is larger than 4 pi over 8, which is pi over 2, so it does not belong. So this is an element of, this is not an element of. So how do you deal with that? In that case, we have to look for an angle whose sine value is the same as 5 pi over 8, and it is within the domain of minus pi over 2 to pi over 2. So we have to find an angle in this interval for which sine is equal to sine of 5 pi over 8. Now, 5 pi over 8 puts us in the second quadrant, in which case sine is positive. So when we look at this restriction, sine is positive in the first quadrant, and it becomes really the reference arc, which is simply 3 pi over 8. So remember, sine is represented by the y coordinate in essence, and the y coordinate is positive in the first and the second quadrant. So we want 5 pi over 8. We can't have it because it doesn't belong here. So corresponding to 5 pi over 8, 3 pi over 8 is the reference arc, and 3 pi over 8 has the same sign. 3 pi over 8 and 3 pi over 8, okay, in this case. So sine inverse of sine 5 pi over 8, we change this to 3 pi over 8 because these two have identical values, and this is within the acceptable domain of minus pi over 2 to pi over 2. Therefore, the answer is 3 pi over 8. So you want to be careful with that. Let's look at cosine. Y equals cosine x. The domain is all real numbers. The range is -1 to 1, and this is not a 1-to-1 function either. It fails the horizontal line test as well. So how do you come up with the inverse? You have to restrict it such that it is a 1-to-1 function. And the restriction takes place from 0 to pi. The reason we cannot use the same domain of minus pi over 2 to pi over 2 because it doesn't cover their whole range of cosine, and they want it to be a continuous function. So mathematicians have decided to go from 0 to pi. It covers everything. Therefore, this portion with the proper restriction of x being between 0 and pi becomes a one-to-one function. So now we define y equals cosine inverse x, means x is cosine y as long as x is between -1 and 1. Remember, the x here is the domain for the inverse and the range for the original function, which is -1 to 1. So this will change to this. And the domain for cosine becomes the range for cosine inverse. So with that being the case, look at these three important points. This point, if I want to graph this, for the inverse becomes 1, 0. This one is pi over 2, 0 becomes 0 pi over 2. And this one is pi minus 1 becomes -1 comma pi. So these are the changes that take place. I want to go with the inverse. So if you plot those carefully, you'll see the inverse function. Again, this is the original cosine function that has been restricted. And now corresponding to those 3 points, 0, 1 becomes 1, 0. Pi over 2, 0 becomes 0 pi over 2. Pi -1 becomes -1 pi. And as you can see, they are symmetric with respect to the line y equals x. Let's look at a couple of examples. Again, just reminding you that if y is cosine inverse x, that means x is cosine y. X is between -1 and 1, the domain, like the range of cosine, and y is restricted between 0 and pi because that was the decision we made on the domain for the cosine. So if this is cosine inverse 0, we can say, okay, we don't know the answer, let it be x, y, z, or theta. By definition, cosine theta becomes 0. So theta, cosine of what angle is 0? That in the interval of 0 to pi, of course, and the answer is pi over 2. It is one of those common ones. Same thing here. We don't know the answer. We set it equal to theta, let's say. You don't have to set equal to theta. You can say it's x. By definition, cosine theta is 1/2. And therefore, what angle whose cosine is 1/2 is 60 degrees or pi over 3. Again, you answer it accordingly. Normally we answer it in radians unless asked otherwise. We do the same thing. We don't know the answer. We call this theta. By definition, it means cosine theta is -1/2. And we look at this, right? Cosine is negative in the second quadrant. So for 1/2 was pi over 3. For -1/2 would be pi minus that. Let me try this for you so that will be helpful. Now, the terminal side makes a pi over 3 angle with the positive side of the x-axis. If this angle is pi over 3, then this is known as the reference arc. Or angle. So reference arc, if you want to find the answer, you look at cosine theta equals 1/2. Theta is pi over 3. And for this one, the reference arc, which we call it theta prime or theta sub r or theta hat, is also pi over 3. But what is the answer we are looking for is this. So the answer is pi minus pi over 3, which is 2 pi over 3. This is the concept known as reference arc or angle. We're going to do the same thing for part D. Notice it's negative. We set it equal to theta. And by definition, cosine theta is minus square root of 2 over 2. So if you want to find that and you have no idea how to find it, let's look at the positive side. We know that if cosine theta is square root of 2 over 2, then theta is pi over 4. In other words, pi over 4 will result in cosine, the same thing for sine, by the way, to be square root of 2 over 2. When we are looking at the negative value, then we have the same reference arc. So in this case, theta prime or theta sub r or theta hat, depending on the text, is pi over 4. Since we want it to be negative, and we are looking for this restriction, it puts us in the second quadrant. And this angle must be pi over 4, the closest angle. The terminal sides makes with the x-axis, either on the positive side or the negative side. That is the definition of the reference arc. So reference arc, reference angle or arc, the angle made by the terminal side with the x-axis. Or we should actually call it the smallest angle. The smallest angle, perhaps it's better. So instead of this, I really want to write the smallest. And so with that being the case, for this one would be pi minus pi over 4, which gives us 3 pi over 4. So I want you to be very comfortable with the concept of reference arc and being able to handle it. All right. Over here again, reminding everyone, in the case of a cosine, if we have cosine inverse cosine, then this x must be between 0 and pi. If it's cosine inverse, this x must be between -1 and 1. As we are looking at this one, and this is between 0 and pi, so simply put, the answer is 5 pi over 6. So this one is between 0 and pi. Point 2, the same thing. In this case, point 2 is between -1 and 1, so the answer is point 2. Point 2, you're looking at this part. Is it between -1 and 1? Yes, because it is. F of F inverse is x. Done. So A and B, pretty straightforward. When we look at this one, the top one says x must be between 0 and pi. As you can see, 5 pi over 4 is larger than that, and therefore we can't say it's equal to 5 pi over 4. 5 pi over 4 doesn't belong to this. 5 pi over 4 is larger than this. So what we need to find an angle whose cosine is 5 pi over 4. Okay. So find an angle with the same cosine value. All right. Now, 5 pi over 4, it's in the third quadrant. And in quadrant 3, cosine is negative. Remember, cosine is positive in the first and fourth quadrant. At 5 pi over 4, I hope you realize the reference arc is pi over 4, just for the sake of argument. But it is negative, and we have to look for this one, which puts us in the second quadrant. So how do we find that pi, if you want, looking like that? This is pi over 4. And in this case, pi over 4 makes it negative. So pi minus pi over 4 makes it 3 pi over 4. Cosine of 5 pi over 4 equals cosine of 3 pi over 4. Therefore, the answer is 3 pi over 4. What happens to part D? This must be between -1 and 1. In other words, if you were to write this cosine, just right here. This is theta, that means cosine theta is 2, and it can never be because cosine is between -1 and 1. And so therefore, it gives you an error, it doesn't exist, it's undefined, however you want to put that. Let's look at tangent, and it doesn't have an inverse either, simply because it runs from negative to positive infinity, and it fails the horizontal line test. So in essence, none of trigonometric functions are one-to-one. None of them has an inverse. So each and every one of them must be restricted, and the restriction takes place by looking at only one complete cycle between negative pi over 2 and pi over 2. Tangents almost follow sine, with the exception that the end points, negative pi over 2 and pi over 2, are not included because those are vertical asymptotes. And that gives you an idea what happens with the rest of it. Cotangent and secant follow cosine. Cosecant and tangent follow sine. But we want to pay attention to the endpoint. So with that being the case, we have y equals tan inverse of x. That means x equals tan y. The domain is all real numbers. The domain is minus pi over 2 to pi over 2 here, becomes the range here. The range is all real numbers, and it becomes the domain here. So let's look at important and easy points. So negative pi over 4, -1, somewhere here. So 0, 0, power 4, 1, vertical asymptotes, x equals minus power 2, x equals power 2. So what happens? This changes to negative 1, negative power 4. This is 0, 0. This is 1 power 4. VA becomes horizontal asymptote. Y equals negative power 2 and power 2. So take a look at the changes that take place. And if we were to graph this, now the graph that went this way, now the inverse goes like that. This had 2 vertical asymptotes. This has 2 horizontal asymptotes. And look at the 3 pairs that we have graphed. So that's as far as the tangent goes. Let's answer a few questions regarding that. Tan inverse of 1. Again, we know that in the case of an inverse, the x can be anything, but the y is between negative power 2 and power 2. So we let it be theta. By definition, tan theta is 1, and you remember that it's a common arc, it becomes power. Same thing here, let it equal theta. By definition, tangent is minus square root of 3. So again, I want to discuss the common arc. So I want to look at the positive value first so we have an idea. So if we look at tan theta being square root of 3, we know that theta is pi over 3. So with the negative, because we go from negative power 2 to power 2, and in the fourth quadrant tangent is negative, it is simply negative power 3. Okay, so pay attention to this. And remember, tangent is positive in the first and third quadrant. So this is equal to theta. By definition, tan of theta is this. It's a common arc, pi over 6 or 30 degrees. Actually, this will help with this one. First, we write this equal to x, y, z theta. Then by definition, tan of theta is that. And again, just as I explained here, we need to work on the positive part. The positive part, we know it to be pi over 6. And because we go from negative to positive power 2, then the answer to this one is negative pi over 6. So it's really a good idea to look at this column and this column simultaneously. When this gives you pi over 6, you can clearly see why this is negative pi over 6. All right, we want to solve the equation that involves inverse functions. For example, 2 cosine inverse of x is pi over 2. First, we're going to divide both sides by 2. This becomes pi over 4. So now we say cosine inverse of x is pi over 4. That means x is cosine of pi over 4. And cosine of pi over 4, we know it to be square root of 2 over 2. 3 sine inverse of x is power 2. We divide by 3, both sides. Sine of power 6 is x, and we know it to be 1/2. And we're done. Five sine inverse minus 2 pi equals 2 sine inverse minus 3 pi. So we are going to move things around. So 3 sine inverse x is negative pi. Divide by 3. By definition, x is sine of negative pi over 3. And I'm sure you know sine is an odd number, odd function. So minus sine of pi over 3, sine of pi over 3 is the square root of 3 over 2. You put the negative sign in front, and that's the final answer. So we looked at a couple of simple examples of equations involving inverse functions. We want to find the inverse for this function, where x is between negative and positive power 2. And then we want to find the range of f and the domain of f inverse. So first, let's find the inverse. And I'm going to go through the process. First and foremost, we call this f of x y, step 1, just to make it easy. So we call f of x y to make it easy. Step 1. I'm reminding you how to find the inverse. Number 1, call f of x y. Number 2, interchange x and y. So change the y to x, change the x to y. Right at this very step, we have the inverse. However, we always solve for y. So we move the negative 1. It's x plus 1. And then we divide by 2. Since we are solving for y, y becomes sine inverse of x plus 1 over 2. And we give it the name f inverse of x. So that's the first step. We got the inverse. The next topic is to discuss domain and range. Here's the domain for the function f of x. That means this is the range for f inverse. Domain is given. Therefore, range of f inverse is the same thing. And by range, we mean y is between those two. Now, let's find the other two. We want the domain of f inverse, which becomes the range of f. So a couple of different ways of handling it. So if we want the domain of f inverse, we look at f inverse. This one has to be between negative 1 and 1, right? Remember, for the inverse function, domain is between negative 1 and 1. So we're going to multiply by 2. This becomes negative 2, this goes away, this becomes 2. We are going to subtract 1. This is the domain of F inverse. Therefore, the range for F is the same thing. And this is fun. I just want to quickly show you if we were to use a different method, and it is possible. And that is to write this one. When we solve for sine x, y equals 2 sine x minus 1. So if we move it to the other side, y plus 1 divided by 2, that sine x must be between negative 1 and 1. So first understand this is given. If I move the negative 1 becomes plus 1 if I divide by 2 sine. From here, sine is y plus 1. So from here, we can go here. And sine must be between negative 1 and 1. And because sine is between negative 1 and 1, so is y plus 1 divided by 2 between negative 1 and 1. And you go through the process, y is between negative 3 and 1, and now you have the range of f this way. If you want, you can find the range of f from here, or since we have the domain of f inverse, we don't have to waste time finding that. So I'm showing you two different ways in case, and I would stick with the easy way out because I found this here. I don't have to do anything. I know domain of one is range of the other. We want to do the same thing here. Here's the function f of x, and here's the domain. So first and foremost, we want to find the inverse. So we're going to call f of x y. We are going to interchange x and y. So this becomes x, this becomes y. And right in this step, we do have the inverse. However, we want to solve for y. And to do that, first and foremost, we're going to divide by 2. So this goes away, this becomes x over 2. And now cosine inverse of the left side, that means cosine inverse of x over 2 is what you see here, 3y plus 2. I hope everybody understands what's going on here. Cosine inverse of x over 2 is 3y plus 2. We are solving for y. We're going to move the 2. And this one we divide by 3. Division by 3 is the same as multiplication by 1/3. So 1/3 of this piece, 1/3 of cosine inverse of x over 2, minus 1/3 of 2, which is 2/3. So this is the inverse. Again, here's f of x, here's f inverse. We went through the process. Domain is given for the f, which is the range for f inverse. So if x is between negative 2/3 and negative 2/3 plus pi/3, the reason they kept it like that is precise. Remember, pi is about 3.14159. And so what is the range for f inverse? The same thing, except you change it to y, okay? So we're done with that. Now, we can go to this and find the domain for this. And remember, this is 1/3 cosine inverse of x over 2 minus 2/3. This is what's important. And this must be between negative 1 and 1. So x over 2 is between negative 1 and 1. Multiply by 2 and you find x. So domain of f inverse is between negative 2 and 2. That means range of f is the same thing between -2 and 2. We could find it the other way around. Going back to this, cosine is between -1 and 1. 2 of that is between -2 and 2. So why is this? Cosine, regardless of what you have here, cosine of whatever is always between -1 and 1. We multiply by 2, so 2 that times that is between -2 and 2. And that's your y. Y is between -2 and 2. So again, I'm giving you both ways in case. You can stick with the easy way out. If you think this method is helpful, by all means. For this function, the domain is given and we want to find f inverse. Again, quickly we change this to y. That's the first step. Interchange x and y. Right here we have the inverse. However, we're going to move this. And we're going to divide by 2. So tan inverse of this expression, x plus 3 over 2 is y. And we're going to change the y to f inverse. So we found the inverse function. What is the domain of f given? That's the range of f inverse. So domain of f is given, so is range of f inverse. Now we are looking for domain of f inverse. And domain of f inverse, whatever this expression is, it's from negative to positive infinity. If you multiply by 2 and then subtract 3, it is still remains as infinity. If you want, I can show you quickly. If I multiply by 2, I get minus 2 infinity less than or equal to x plus 3 less than or equal to 2 infinity. And if I subtract 3, it really makes no difference. So I can say minus 3 minus 3. Please understand this is still negative infinity. And this is still positive infinity. Infinity times 2, infinity times 10, infinity minus 10 billion, they're all infinity. And so is the range of f. If we were to use a second method, we could use this one. We have this y, because it's dealing with tangent. This tangent is between negative and positive infinity. 2 times that minus 3 is also between negative infinity and pi. So because of this, we know this one to be true. And if you multiply it by 2 and minus 3, it is still, which becomes y, it is still between negative and positive infinity. Let's look at the last question. We want to find the inverse for this function. And so first thing first, we call it y. So the very first step is to change the name to y because it makes it easy to work with. The second thing is to interchange x and y. The next thing is to subtract 1. So you can say 3 cosine y is x minus 1. The next one is to divide by 3. And now you can say cosine inverse of the right side is y. And now you give it a name, f inverse. So we found the inverse function. This is given. This is the domain of f, and therefore the range of f inverse is between 0 and pi also. Again, recall that the domain of f is the range of f inverse, and the range of f is the domain of f inverse. I'm reminding you everything that we've been doing. The domain of f is given. That means the range of f inverse is given. So let's find the domain of f inverse. Cosine inverse of x minus 1 over 3. This piece must be between -1 and 1. Cosine inverse must be between -1 and 1. Let's multiply by 3. This becomes -3. This becomes +3, and this goes away. Let's add 1. And that's the answer. This is the domain of f inverse, which is the range of f as well. You could go with the second method and work on this, because you know cosine is between -1 and 1, multiplied by 3 and add 1. If we were to do that, cosine is between -1 and 1. 3 cosine is between -3 and 3. If I add 1 to all sides, I get to the same answer.